So this is the second part of chapter 3.3, and our objectives in this part of this section is to create box plots and find outliers and use the z-score to determine either a major or minor outlier or outliers. So we're going to find outliers using a box plot. Our method is the IQR method. And this is one of the most frequent methods used to detect outliers, especially if data is not necessarily normal. To do this method, the first step is to find the first quartile and the third quartile using the 5-number summary. So you want to do the 5-number summary first, and typically we would do that on our TI-83 calculator. We can also do it on Excel. The next step is to compute the interquartile range. The interquartile range is Q3 minus Q1. Okay, so it's IQR is equal to Q3 minus Q1. The third step is to compute the boundaries where the outliers may be. And we'll call these the cutoff points. But in our case, we're going to call them fences. And we're going to use these fences in the box plot. So the lower fence is Q1 minus 1.5 times IQR. And the upper fence is Q3 plus 1.5 times IQR. You will notice we use 1.5 because it's half of 3. And remember, our z-score values are either greater than 3 or minus 3, that the whole entire data set is. So we divide it in half, and so that's the reason why 1.5 is used. Step number 4 is that once we have the upper and lower fence, we then can identify values that are either lower or higher than the fence, and these will be considered to be outliers. So in drawing a box plot, we're going to use the upper and lower fences and the maximum and minimum values to draw a number line for the variables. So we would start our number line, we would draw it as x. Here would either be a minimum or maximum value. Up here would be a minimum or this would be a maximum value or the upper fence. This would be the minimum value or the lower fence. Whichever is the furthest away from each other is what we're going to be using. Step number 2 is then once we have our scales, we're going to put in a box where Q1 is to Q3, right? So our box is such that it's on the scale such that wherever this is going to be Q1 and this is going to be Q3. We're also going to put the median in wherever the median is, right, inside the box. Then we're going to draw the whiskers at the lower end or at the upper end. But what we're going to do is we're going to dot in where our fences are. So we'll dot in where our fences are on the line, and then the value closest to the fence, but not over the fence, is where our whiskers are going to be. So in the data set, it's going to be the value that is closest to the fence, but not over the fence. And so our whiskers are going to be on both sides, closest to the fence, but not over the fence, right? And then finally, we will identify our outliers. If there's an outlier, we will certainly put them into our data set. So now we're going to show you an actual example. So here's an example. The following table presents the number of students absent in a middle school in northwestern Montana for each school day in January. Identify any outliers. So here's our data set, right? And then we have a 5-number summary. So we got this 5-number summary from our calculator. The minimum value is 41. Q1 is 45. The median is 51. Q3 is 59, and the max is 100. Now we want to calculate IQR. IQR is Q3 minus Q1, so we take 59 minus 45, and IQR is 14. And so now we're going to calculate our upper and lower fences. Our upper fence is going to be 59, which is Q3, plus IQR times 1.5, which is 80. And the lower fence is going to be 45 minus 1.5 times 14, which is 24. Right? So we have to make sure that we get all the values on the number line. Here's our X value on the number line for the number of days absent. Right? The first mark is at 20. This mark is at 100. Right? Our scale looks a little off because of the way PowerPoint comes into this particular software package. But you can see that Q1, right, is at 45. Right? So here's Q1 right here. And here is Q3 at 59. Right? We haven't put in the median value. The median value is at 51, which we want to put in. And so here is our median value. And then we draw our whiskers. Right? Our fences, right? Our lower fence is at 24, so we would draw a dotted line there. And then we at 80 is right here. So you notice that we have the values close to 80. The closest value to 80 is 77. So that's our top whisker. Our lower whisker is the minimum value, and in this case the minimum value was at 41. Right? So that became our whisker down here. And then in this particular case we have one outlier. The outlier is at the maximum at 100. So our box plot allows us to look at extreme values in kind of the shape of the data. It's kind of skewed to the right, and certainly that value 100 is having a major impact on the data set. So we want to check to see if this data set was approximately normal, would this outlier be a major or minor outlier in the above example? So for values above or below the fence, we calculate a z-score of these observations. If the z-score is between 2 and 3, or negative 3 and 2, the observation is called a minor outlier. If the z-score is greater than 3 or less than minus 3, it's a major outlier. So in the above example, we see that 100 is identified as an outlier, and its z-score value, it turns out to be 3.17. And how did we get the z? Well, we get 100 minus the mean value of 55.4, or 14, divided by 14.16, and we get this value here. So in this particular case, we have a major outlier that we have to contend with in this data set. This concludes chapter 3.3. We will be doing some problems in class of this type, and we will be using the TI 83 and 84, and we'll show those things on using the problems in class.